Which one of the following can be beaten into thin sheets? What does beaten into thin sheets mean? The property of beaten into thin sheets is known as malleability, and this is the property of metals. Out of the four options, phosphorus, this is a non-metal, sulfur is a non-metal, and oxygen is a non-metal. The only metal in this is zinc. So zinc can be beaten into thin sheets, so this is the correct option. Answer is A, option A. Which of the following statements is correct? All metals are ductile, all non-metals are ductile, generally metals are ductile, some non-metals are ductile. Ductile means it can be drawn into wires. Ductility is the property of being drawn into wires. You can make wires out of these metals. The correct option is generally metals are ductile. All metals are not ductile. There are some metals which exist in liquid state like mercury. So it will not be ductile. Some metals are very soft like sodium. So it will not be ductile. All non-metals are ductile? No, non-metals are neither ductile nor malleable. Some non-metals are ductile? No. So correct option is generally metals are ductile. Means most of the metals are ductile except few metals which are either soft or exist in liquid state, and they cannot be beaten into sheets and they cannot be drawn into wire. So correct option is option C. Some properties are listed in the following table. Distinguish between metals and non-metals on the basis of these properties. First, appearance. Metals have metallic luster. Non-metals are dull. Hardness. Metals are hard. Non-metals are generally soft. Exception is sodium. Sodium is a soft metal. Mercury exists in liquid state. Malleability. Metals are malleable. That is, they can be beaten into sheets. Non-metals are non-malleable. Then ductility. Metals are ductile. That is, they can be drawn into wires. Non-metals are not ductile. They cannot be drawn into wires. Heat conduction. Metals are good conductors of heat, whereas non-metals are not good conductors of heat. Conduction of electricity. Again, metals are good conductors of electricity, whereas non-metals are not good conductors of electricity. Match the substances given in column A with their uses given in column B. Gold. Gold will match with jewelry. Then iron. Iron is used in machinery. Aluminium. Aluminium is used in wrapping food. Carbon. Carbon is used as fuel. Copper. Copper is used in electric wires. Mercury. Mercury is used in thermometer. Phosphorus is a very reactive. The answer is reactive non-metal. Metals are good conductors of heat and electricity. All the cooking utensils are made up of metals. The reason is metals are good conductors of heat. All the electrical wires are made up of metals. Reason behind is metals are good conductor of electricity. Iron is more reactive than copper. This is the reason why copper salts like copper sulfate are not kept in iron vessels. Metals react with acids to produce hydrogen gas, like magnesium metal plus HCl will form magnesium chloride and hydrogen gas, half H2. Mark T if the statement is true and F if it is false. Generally, non-metals react with acids. Non-metals do not react with acid. So this statement is false. Sodium is a very reactive metal. True. Copper displaces zinc from zinc sulfate solution. False. Zinc is more reactive than copper. So zinc will displace copper from copper sulfate solution. Coal can be drawn into wires. False. Coal is made up of carbon, which is a non-metal. Coal cannot be drawn into wires. Question. Paheli prepared a blue colored solution of copper sulfate in a beaker. Copper sulfate in beaker A and placed an iron nail in it. Bhojo prepared a yellowish green solution of ferrous sulfate in beaker B and placed a copper wire in it. What changes will they observe in the two beakers after an hour? The order of reactivity of copper and iron is more reactive than copper. Therefore, when iron is kept in a solution of copper sulfate, then iron will replace copper from its salt. What will happen? Iron will combine with the sulfate ion, forming iron sulfate, and metallic copper will be deposited in the vessel. The color of this copper sulfate solution is blue. So in beaker A, blue color copper sulfate solution is there, and when iron nails are placed in it, slowly what happens? Iron replaces copper from copper sulfate, forming iron sulfate and copper. Slowly blue color of the solution fades and it develops a yellowish green color. Now the color of the solution changes from blue to yellowish green because yellowish green color is the color of ferrous sulfate. And metallic copper is deposited in the beaker. The metallic copper is of reddish brown color. Now what happens in beaker B? Beaker B, ferrous sulfate is taken along with copper. Ferrous sulfate is taken along with copper. Copper is in the form of copper wire. Now in this case, no reaction takes place. Why? Because iron is more reactive than copper. Copper is less reactive than iron. So copper will not replace iron from its salt. As a result, the color of solution in beaker B remains yellowish green. So the changes observed in the two beakers after an hour. Beaker A, color of the solution changes from blue to yellowish green. Reason, iron displaces copper from its salt. Iron forms iron sulfate and metallic copper is deposited. Beaker B, the color of the solution remains yellowish green because copper, being less reactive, will not displace iron from its salt. And the color of the solution remains yellowish green. Generally, when metals are treated with mineral acids, hydrogen gas is liberated. But when metals except manganese and magnesium are treated with HNO3, hydrogen is not liberated. Why? The reason is HNO3 acts as oxidizing agent. And it oxidizes hydrogen to water. For example, when zinc is treated with HNO3, it forms zinc nitrate and hydrogen gas. This is the balanced equation. Now this hydrogen gas which is formed is oxidized by nitric acid into H2O, and NO2 gas is also formed. The balanced equation will be 2 HNO3, 2 hydrogen, 2 nitrogen and 6 oxygen. 2 hydrogen, here also 2 NO2, so that 2 nitrogen, and for 6 oxygen, here also 2 H2O. Now this equation is balanced. Total hydrogen on the reactant side is 4 Total nitrogen on the reactant side is 2. Total oxygen on the reactant side is 6. And on the product side, total hydrogen is 4. Total nitrogen is 2 and total oxygen is 6. So adding these two equations, the final equation is hydrogen cancels, and this is zinc plus 4HNO3 forming zinc nitrate plus 2H2O plus 2NO2. So whatever hydrogen is formed during the reaction of nitric acid with the metal is oxidized by HNO3 into H2O. This is the reason why metals except manganese and magnesium, when treated with HNO3, hydrogen is not liberated. Manganese and magnesium also liberate hydrogen with very dilute HNO3. Manganese and magnesium will liberate hydrogen with very dilute HNO3, and other metals with HNO3 will form the metal nitrate, water and nitrogen dioxide gas. Saloni took a piece of burning charcoal and collected the gas evolved in a test tube. How will she find the nature of the gas? Second, write down word equations of all the reactions taking place in this process. Charcoal means carbon. So reaction can be written as carbon plus oxygen forming carbon dioxide. This is the reaction which takes place when the charcoal is burnt in air. Now this carbon dioxide when it reacts with water, it forms carbonic acid. So how to find the nature of the gas? If a wet blue litmus paper is brought near the gas, this blue litmus will turn to red. Blue litmus will turn to red, which means the gas is acidic in nature. When wet litmus paper is brought near the gas, what happens? The carbon dioxide reacts with the water, forming carbonic acid, which turns blue litmus to red. Thus, it can be said that nature of the gas is acidic. One day, Rita went to a jeweler's shop with her mother. Her mother gave gold jewelry to the goldsmith to polish. The next day, when they brought the jewelry back, they found that there was a slight loss in its weight. Can you suggest a reason for the loss in weight? To polish the gold jewelry, it is kept in acidic solution, and some of the gold reacts with this acid, because of which there is loss in the weight of the gold jewelry. Question: why should the metal sulfide and carbonate be converted to metal oxides in the extraction process of metal? The reason is, it is easy to extract the metal from its oxides than from carbonate or sulfide. Carbonate of a metal is converted into its oxide by the process of calcination. What is calcination? Calcination means heating anything in the absence of air or oxygen, or heating in a limited supply of air or oxygen. And sulfide ores are converted into their oxide by a process known as roasting. What is roasting? Roasting means heating in the presence of air or oxygen. Once the carbonate and sulfide ore is converted into oxide, metals are obtained from this oxide by a process of reduction. Pahili bought a statue made of copper. To her surprise, it acquired a dull green coating after a couple of months. Explain the reason. See, statue is made of copper. Now, in the air, moisture is present, oxygen is present. So, copper will react with this moist air, as a result of which it forms copper hydroxide and copper carbonate. This copper hydroxide and copper carbonate These two result in the dull green coating. The dull green coating is due to this basic copper carbonate which is formed. It is called basic copper carbonate because it is formed along with copper hydroxide. So as a result of formation of this basic copper carbonate, a dull green coating is formed on the statue. This green coating is of basic copper carbonate. Which of the following metals can displace the other two metals from their salt solutions? Zinc, iron, copper. Zinc is more reactive than iron. Iron is more reactive than copper. Zinc will displace iron from its salt solution, and zinc will also displace copper from its salt solution. So zinc is the metal which can displace both iron and copper from its salt solution. So the answer to this question is zinc. Match column A with column B. Column A, list of substances is given. Column B, application is given. Oxygen, application of oxygen is all living beings inhale during breathing. Copper, application of copper is for making electric wires. Sulfur, application of sulfur for making crackers. Iron, application of iron for making rails. Chlorine, application of chlorine is for disinfecting water. Some of the following statements are incorrect. Find the incorrect statements and correct them. A. The property of metals by virtue of which they can be drawn into wires is called ductility. This statement is correct. Metals are good conductors of electricity but poor conductors of heat. This statement is wrong. Metals are good conductor of electricity as well as they are good conductors of heat. The correct statement will be metals are good conductors of electricity as well as they are good conductors of heat. Articles made of metals produce ringing sound when struck hard. Correct. That's why metals are also called sonorous. This property of metals producing ringing sound when struck hard is called sonority. And metals are sonorous, that is, they produce ringing sound when struck hard. Oxides of non-metals and metals are acidic in nature. Again, this statement is wrong. Oxides of non-metals are acidic in nature, but oxides of metals are basic in nature. Oxides of metals are basic in nature. Oxide of non-metals are acidic in nature. Oxides of metals are basic in nature. They are not acidic in nature. A less reactive metal replaces a more reactive metal from its salt solution in water. Wrong. A more reactive metal, here instead of less, this will be more. A more reactive metal, here instead of more, this will be less. So the correct statement will be a more reactive metal replaces a less reactive metal from its salt solution in water. For example, iron is more reactive than copper. Therefore, iron replaces copper from its salt solution. For example, in a solution of copper sulfate in water, if iron is added, iron will replace copper from its salt solution and this becomes iron sulfate and metallic copper is formed. Whereas the less reactive metal will not replace the more reactive metal from its salt solution. That is, if copper is taken with iron sulfate, then no reaction will take place. No reaction will take place. Copper will not replace iron from its salt solution in water. So statements B, D and E are wrong. These are the incorrect statements. Statement B, D and E are incorrect. Name two soft metals which can be cut with a knife. Two soft metals which can be cut with a knife are sodium having symbol Na and potassium having symbol K. Which non-metal is essential for our life and all living beings inhale it during breathing? Answer is oxygen. Symbol is O. Which non-metal is used to disinfect water? Answer is chlorine, and it is represented by Cl. Why are bells made of metals? Bells are made of metals because of the property of sonority of metals. Metals are sonorous. What is the meaning of sonorous? Sonorous means they make a sound when struck. Elements can be classified as metals and non-metals on the basis of their properties. The properties are either physical properties or the chemical properties. Now first, the physical properties of the metals. To study the physical properties of metals, metals which are easily available are selected like iron, copper, aluminium, magnesium, sodium, lead, zinc. Now in this activity 1, the property that is discussed is metallic luster. All the metals have metallic luster. What do you mean by metallic luster? It means that all the metals have a shining surface. Now condition is metals in their pure state have a shining surface. Very common example of metals having shining surface is gold and silver. Gold and silver, they have shining surface. Gold is the most unreactive metal, so its surface remains shining for a very long period of time, because of which gold and silver are used in making jewelry. But other metals like iron, copper, they get coated with a layer of their oxide or carbonate. These metals are reactive metals. When they come in contact with the oxygen and moisture and carbon dioxide of the air, they may react with these gases of the air and a coating of either oxide, carbonate is formed on their surface and their surface becomes dull. But if these metal surfaces are rubbed with sandpaper, this coating is removed and the shining surface can be seen again. So it can be said that all the metals, they have a metallic luster, and those metals which are less reactive or which do not react, they retain their luster for a long time. Common example, gold and silver, and these are used in making jewelry. Second activity discusses the hardness of the metal. Now usually the metals are hard like iron, copper, aluminium, magnesium. It is not possible to cut these metals with knife. But exception to this are the metals like sodium and potassium. These metals are soft metals. They can be cut with knife. So it can be said that the metals are generally hard, but the hardness varies from metal to metal. Now sodium and potassium metals, these are very reactive metals, because of which these metals are kept under kerosene. Sodium and potassium metals are very reactive metals. These metals, if they come in contact with air, they may react with the oxygen and moisture of the air, and the reaction is very vigorous reaction, and sodium metal may also catch fire when comes in contact with air. Third activity discusses the property of malleability of metals. Now, what is malleability of metals? Malleability means metals can be beaten into thin sheets. If metal is struck with a hammer, then this metal will change. A block of metal can be changed into a sheet of metal. Common example of metal sheet is sheets of iron. Another example of a metal sheet is aluminium foil, which is used for wrapping food. Next property of metal is ductility. What is ductility? Ductility means metals can be drawn into wire. Iron, copper, gold, all these metals, They can be drawn into thin wires, and in the electrical circuit, copper wire is used. Gold, because of its property of ductility and malleability, is used to make jewelry. The most ductile metal is gold. The most malleable and ductile metal is gold. Now, because of the malleability and ductility, metals can be given different shapes according to our needs. Since the metals can be beaten into sheets, metals can be drawn into wires, metals can be given different shapes according to the needs. The utensils are made up of metals, the jewelries are made up of metals, the wires, the electrical wires are made up of metals. Now, next activity discusses the property of the conductivity of metals. Metals are good conductors of heat and they have high melting points. Now, this is the activity. This is a stand, this is a clamp, a metal wire is fixed to this clamp. One end of the metal wire is fixed to the clamp. Other end of the metal wire, a pin is attached with the help of wax. Now, end of the metal which is clamped is heated with the help of a burner. After some time, the wax melts and the pin falls down. So, what is the inference? The inference is heat can travel from one end of the metal to the other end of the metal. So, metals are good conductors of heat. They can conduct heat from one end to the other end. Second thing is, though the metal is heated for a long time using this burner, this metal does not melt, which means that the metals have high melting points. So, best conductors of heat are silver and copper, and lead and mercury are comparatively poor conductors of heat. So, in short, whatever properties are discussed till now, metals, they are usually hard. Exception is sodium and potassium. These are the soft metals. Metals are generally in solid state. Exception is mercury, which is found in liquid state. Metals have shining surface unless and until they get coated with the layer of their oxide or carbonate. Metals are good conductors of heat like silver and copper, which are the best conductors of heat, but poor conductors of heat are lead and mercury. Then malleability and ductility. Metals are malleable, that is, they can be beaten into sheets. Metals are ductile, they can be drawn into wires. Best example of malleability and ductility is gold. Gold is the most malleable and most ductile metal, and because of this property of gold, it is used to make jewelry. Next property of metals is whether they are good conductors of electricity or not. Now, this is a circuit, and if a piece of metal is connected between the terminals A and B, this bulb will glow, which shows that metals are good conductors of electricity. Now, all the electrical wires, they have a coating of polyvinyl chloride or a rubber-like material. Now, what is the reason behind this? This wire, electric wire, which is made up of metal, is a good conductor of electricity. So, it is always coated with some bad conductor of electricity. For example, a rubber-like material, that is polyvinyl chloride, to prevent shock due to electric current on touching the wire. What happens when metals strike a hard surface? When metals strike a hard surface, they emit sound, and this property of metals is known as sonority, or metals are said to be sonorous, meaning they make a sound when they are struck on a hard surface. Non-metals, example of non-metals are sulfur, iodine, oxygen, hydrogen, carbon, etc. And non-metals are either solids or gases except bromine, which is liquid. So, a non-metal which is liquid is bromine. Now, comparing the properties of metals and non-metals, in table 3.1, an element which is a metal and element which is a non-metal can be taken and comparison of the properties can be made. Now, first point, all metals exist in solid at room temperature, exception is mercury. Mercury exists as liquid at room temperature. Metals have high melting points, but gallium and cesium, they have very low melting points. These two metals will melt if you keep them on your palm. A non-metals are usually not lustrous, they do not have shine, they are dull, they do not have shiny surface, but iodine is a non-metal which is lustrous, so iodine is exception here. Carbon is a non-metal and it exists in different forms. The different forms of carbon are called its allotrope. One of them is diamond, which is hardest natural substance known and has very high melting and boiling point. Graphite is another allotrope of carbon and it is a good conductor of electricity. Now graphite is not hard like diamond, graphite is soft and it is a good conductor of electricity. Alkali metals, lithium, sodium, potassium, they are so soft that they can be cut with a knife. They have low densities and low melting points. So type of surface, metals usually have shiny surface and non-metals have dull surface. Hardness, metals are usually hard, exception is sodium and potassium which are soft metals. Non-metals are usually not as hard as metals. Diamond, which is allotrope of carbon, is the hardest substance known. Otherwise, non-metals are usually soft. Malleability, metals are malleable, non-metals are not malleable. Ductility, metals are ductile, non-metals are not ductile. Conduction of electricity, conducts electricity, metals are good conductors of electricity, non-metals are poor conductors of electricity. Sonority, metals are sonorous, non-metals are not sonorous. Now, on the basis of chemical properties, metals and non-metals can be distinguished. For example, take a magnesium ribbon and some sulfur powder. Magnesium is a metal, sulfur is a non-metal. Burn the magnesium ribbon in air. When magnesium is burnt in air, it forms magnesium oxide. Magnesium oxide is a white powder. Now, this magnesium oxide, when dissolved in water, it gives a solution which turns red litmus to blue. Next, sulfur powder. Burn the sulfur powder. Place the test tube over the burning sulfur to collect the fumes produced. Sulfur burns in air to form sulfur dioxide gas. Add some water to the above test tube and shake. What happens? Sulfur dioxide will dissolve in water, giving sulfurous acid. Now this solution of sulfurous acid will turn blue litmus to red. Is the product formed on burning sulfur acidic or basic? The product formed on burning sulfur is acidic. And the product formed on burning magnesium is basic. So metal oxides are basic in nature. Solution of metal oxides turn red litmus to blue, and non-metal oxides are acidic in nature, that is, the solution of non-metal oxides turn blue litmus to red. So most non-metals produce acidic oxides when dissolved in water. On the other hand, most metals give rise to basic oxides. Now questions. Give an example of a metal which is a liquid at room temperature. Mercury. Can be easily cut with knife. Sodium. Is best conductor of heat. Copper. Is a poor conductor of heat. Lead. Explain the meanings of malleable and ductile. Malleable means it can be beaten into sheets. Ductile means it can be drawn into wire. Chemical properties of metals. The first one is reaction of metals with oxygen of the air. So what happens when metals are burnt in air? Magnesium burns in air with a dazzling white flame and it turns to magnesium oxide. Now this oxide is then dissolved in water and the nature of the solution is checked whether it is acidic or basic. Almost all metals combine with oxygen to form metal oxides. So general reaction is metal plus oxygen forming metal oxide. Now when copper is heated in air, it combines with oxygen to form copper 2 oxide, a black oxide. What is the meaning of copper 2 oxide? Copper 2 oxide means that the oxidation number of copper in this oxide is 2, or the valency of copper is 2. So copper burns in air, it combines with the oxygen of the air to form black color oxide, which is copper oxide. The reaction is Cu plus O2 forming CuO. Similarly, aluminium forms aluminium oxide. Aluminium combines with oxygen of the air to form aluminium oxide. Now this aluminium oxide reacts with acid as well as with base. When it reacts with acid, it acts as a basic oxide, and when it is reacting with a base, it is acting as an acidic oxide. Therefore, oxide of aluminium is also known as amphoteric oxide. Product formed when aluminium oxide reacts with acid, that is HCl, is AlCl3 plus water, and when it reacts with NaOH, it forms NaAlO2 plus water. Similarly, oxide of zinc is also amphoteric. Zinc oxide reacts with HCl to form zinc chloride plus water, and zinc oxide also reacts with NaOH to form Na2ZnO2 plus water. This is sodium zincate. Na2ZnO2 is sodium zincate. So sodium zincate plus water. Now balancing the equation, this is 2HCl and this will be 2NaOH. Most metal oxides are insoluble in water. Most of the metal oxides are insoluble in water, but some dissolve in water to form alkalis. For example, sodium oxide dissolves in water to form NaOH. This aqueous solution of NaOH is known as alkali. Potassium oxide dissolves in water to give potassium hydroxide. Now, metals do not react with oxygen at the same rate. Different metals show different reactivities. Different metals show different reactivities. Means some metals react very vigorously, some react at a moderate speed, and some react very slowly with oxygen. So different metals show different reactivities towards oxygen. Metals such as potassium and sodium. So potassium and sodium, they react vigorously that they catch fire if kept in open. So to protect them and to prevent accidental fires, two reasons: to protect sodium and potassium from reacting with air, from reacting with oxygen present in air, and to prevent accidental fires, they are kept immersed in kerosene oil. So which two metals are kept immersed in kerosene oil? Potassium and sodium. At ordinary temperature, surfaces of metals like magnesium, aluminium, zinc, lead are covered with a thin layer of oxide. They are covered with a thin layer of oxide, and because of this reason, these metals, they lose their luster. Aluminium loses its luster when kept in air because of the formation of layer of oxide on its surface. The protective oxide layer prevents the metal from further oxidation. So what is the role of this oxide layer? This layer of oxide prevents the metal from oxidation. Next, iron does not burn on heating, but iron filings burn vigorously when sprinkled in the flame of the burner. Copper does not burn, but the hot metal is coated with a black colored layer of copper oxide. Copper does not burn, but if it is hot, it gets coated with a layer of copper oxide. Silver and gold do not react with oxygen even at high temperatures. So most reactive metals are sodium and potassium, which react vigorously with oxygen of the air even at ordinary temperature, even at normal temperature. Then magnesium, it burns in air. Then at ordinary temperature, magnesium, aluminium, zinc, they get coated with a layer of oxide which prevents them from further oxidation. Iron does not burn on heating, but iron filings burn vigorously when sprinkled in the flame. Copper also does not burn, iron does not burn, copper does not burn, but if copper metal is hot, then it gets coated with a layer of copper oxide. The most unreactive metals are silver and gold. These do not react with oxygen even at high temperature. So most reactive are sodium and potassium, and which do not react with oxygen even at high temperature are silver and gold. Now there is a process which is known as anodizing. Anodizing or anodization. What is this process? It is a process of forming a thick layer of oxide of aluminium on the surface of aluminium. When aluminium is kept exposed to the air, then it develops a thin layer of its oxide on its surface. But if you want a thick layer of oxide, aluminium oxide on the surface of aluminium metal, then anodization is the process. So during anodizing, what happens? A clean aluminium article is made at the anode. This is made the anode, and electrolyte used is dilute sulfuric acid. The oxygen gas which is evolved at the anode combines with aluminium and forms a thick protective layer of aluminium oxide. This layer of oxide can be dyed easily to give aluminium articles an attractive finish. So most reactive metal is sodium. Magnesium, less vigorous reaction. It is not as reactive as sodium. Now there are some other reactions which will help in deciding the reactivity of metals. Why is sodium kept immersed in kerosene oil? Sodium is a very reactive metal. It is a very reactive metal, and when it comes with contact with oxygen and moisture of the air, it reacts explosively and may catch fire. Therefore, it is kept immersed in kerosene oil. Kerosene oil prevents the contact between sodium and the oxygen and moisture present in the atmosphere, and hence prevents the sodium from reacting explosively. Write equations for the reaction of iron with steam. First, iron reacts with steam to form mixture of oxides, that is FeO and Fe2O3. This is iron 2 oxide and this is iron 3 oxide. Here the oxidation state of iron is 3 and here the oxidation state of iron is 2. So combined oxides, it is written as Fe3O4 plus hydrogen gas is given out. Balanced equation will be, this is 3Fe and this will be 4H2O, this will be 4H2. Hydrogen gas is given out. Second, reaction of calcium and potassium with water. Calcium reacts with water to form calcium hydroxide and hydrogen gas. The balanced equation will be, this will be 2H2O. So this is the balanced equation. Now calcium reacts with cold water and gives calcium hydroxide and hydrogen gas. Next is reaction of potassium with water. Potassium reacts explosively with cold water and gives potassium hydroxide, hydrogen and heat energy. So potassium plus water will form potassium hydroxide plus hydrogen gas plus heat energy will be given out. The balanced equation will be, this will be 2KOH, here it will be 2 and here it will be 2H2O. So total number of potassium, oxygen and hydrogen on both the sides of the equation are the same now. Now here Fe3O4 is solid, hydrogen is gas. Calcium hydroxide, it is formed in the form of, present in the form of its aqueous solution. Hydrogen is present as a gas. And here potassium hydroxide, you get a solution of, aqueous solution of potassium hydroxide, hydrogen gas and heat. It is this heat which is produced during this reaction which makes the reaction explosive. This large amount of heat which is produced during the reaction of potassium with water causes hydrogen to catch fire. Activity 3.10. Collect sample of same metal, put small pieces of the samples in beakers half filled with cold water. Which metals reacted with cold water? Sodium and potassium. Did any metal produce fire on water? Sodium will produce fire on water. Does any metal start floating after some time? Calcium. Metals that did not react with cold water, magnesium. For metals that did not react with hot water, arrange the apparatus and observe their reaction with steam. Aluminium, iron and zinc, they will react with steam to form oxide, give hydrogen gas. Metals, gold, silver, lead, copper, these metals will not react with steam. Now this is the arrangement. Metal kept is heated in the presence of water, and whatever gas is formed is collected in this test tube by the downward displacement of water. So metals react with water and they produce metal oxide and hydrogen gas. Now metal oxides which are soluble in water will further dissolve in water to form metal hydroxide. That is, metal oxide plus water will form metal hydroxide. Now all metals do not react with water. Sodium and potassium will react violently with cold water. In case of sodium and potassium, the reaction is violent and exothermic. Exothermic means during the reaction, heat energy is given out. So when potassium and sodium react with water, potassium forms potassium hydroxide, sodium forms sodium hydroxide. Hydrogen gas is evolved. Such a large amount of heat is evolved that whatever hydrogen gas is given out during the reaction catches fire. The reaction of calcium with water is less violent. The heat evolved is not sufficient for hydrogen to catch fire. In this reaction also heat is evolved, but amount of heat evolved is less, so hydrogen produced will not catch fire in this case. So calcium reacts with water to form calcium hydroxide and hydrogen gas is given out. Now these hydrogen gas bubbles of these hydrogen gas, they stick to the surface of calcium, because of which calcium starts floating. So calcium starts floating because the bubbles of hydrogen gas stick to the surface of the calcium metal. Magnesium will not react with cold water, does not react with cold water. Instead it reacts with hot water to form magnesium hydroxide and hydrogen gas is given out. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. Now metals like aluminium, iron and zinc do not react either with cold water or hot water, but they react with steam to form metal oxide and hydrogen. Now aluminium and iron, they are reacting with steam. Now here in this equation it can be seen that water is in gaseous state. Gaseous state means aluminium and iron are reacting with steam, and aluminium and iron are forming their oxides. Aluminium is forming Al2O3 plus hydrogen, iron is forming Fe3O4 plus hydrogen gas. So other metals like sodium, potassium, calcium, magnesium, they were forming the hydroxide and giving hydrogen gas, but aluminium and iron, they are reacting to give oxide and hydrogen gas. Now metals such as lead, copper, silver and gold do not react with water at all. Means they will neither react with cold water nor hot water nor steam. Lead, copper, silver and gold. What happens when metals react with acids? Metals, when they react with acid, they will give salt and hydrogen gas is evolved. Now in sodium chloride, sodium ion has positive charge and chloride ion has negative charge. Sodium and chloride ion are held together by electrostatic forces of attraction. Strong electrostatic forces of attraction. So sodium chloride does not exist as molecules but aggregates of oppositely charged ions. Means sodium ion is surrounded by chloride ions and each chloride ion is surrounded by sodium ions, which are held together by electrostatic forces of attraction. And this kind of compounds which are held together by electrostatic forces of attraction are termed as ionic compounds. Now next example is example of magnesium chloride. The atomic number of magnesium is 12. Its electronic configuration is 282 and it has 2 electrons in its valence shell. Now when it loses the 2 electrons in the valence shell, it forms magnesium ion, that is Mg2 plus ion, and the electronic configuration of magnesium ion is 2,8. This configuration is neon-like configuration. Now, chlorine. Chlorine has atomic number 17. Its electronic configuration is 287. It has 7 electrons in its valence shell. It gains 1 electron and changes to chloride ion, which has electronic configuration 288, which is very much similar to argon. Now, as can be seen, magnesium gives 2 electrons, whereas chlorine accepts only 1 electron. Therefore, to accept 2 electrons, one magnesium atom combines with 2 chlorine atoms. So, magnesium gives 2 electrons. 1 electron is accepted by 1 chlorine atom and the second electron is accepted by the second chlorine atom. So, formula for magnesium chloride becomes MgCl2. Chlorine surrounded by 7 electrons, which are its valence electron, and 1 electron it has from magnesium. So, each magnesium atom combines with 2 chlorine atoms. And from the charge it can be seen that magnesium ion has 2 units of positive charge and each chloride ion has 1 unit of negative charge. So, to neutralize the 2 units of positive charge, magnesium will combine with 2 chloride ions to form MgCl2. So, each magnesium ion has 2 units of positive charge. Each chloride ion has 1 unit of negative charge. So, 2 chloride ions in total will have 2 units of negative charge. So, in magnesium chloride, the 2 units of positive charge on magnesium will be neutralized by 2 units of negative charge coming from 2 chloride ions. So, formula for magnesium chloride will be MgCl2. Samples of 4 metals A, B, C and D were taken and added to the following solution one by one. The results obtained have been tabulated as follows. So, first A is added to a solution of iron sulfate, then to the solution of copper sulfate, then zinc sulfate and then silver nitrate. These are the 4 solutions. First A is added to all these 4 solutions, then B, then C and then D. And the observations were noted. Now it can be seen that A shows no reaction with iron sulfate, but it shows displacement reaction with copper sulfate. B shows displacement reaction with iron sulfate. Then C, displacement reaction with silver nitrate, and D, no reaction. It does not react with any of these solutions. Now if any metal M reacts with any salt, for example take copper salt, CuSO4, and it displaces copper from its salt, means if you get the sulfate of the metal, so metal displaced copper from its sulfate and it formed the sulfate, metal sulfate was formed and metallic copper is deposited. So what has happened? This metal has displaced copper from its salt, forming metal sulfate, and now metallic copper is deposited. So in this kind of reaction, it will be said that the metal is more reactive than copper. This is a single displacement reaction, and metal which displaces the other metal from its salt is said to be more reactive than the metal which was present in the salt. So here metal M is more reactive than copper. Now 4 kinds of salt are taken. One is iron sulfate, then another one is copper sulfate, then zinc sulfate and then silver nitrate. So the reactivity order of these metals is zinc is more reactive than iron, iron is more reactive than copper, and copper is more reactive than silver. So going down from zinc to iron, the reactivity decreases. Means zinc is more reactive than iron, means zinc displaces iron from its salt. Zinc is more reactive than copper, so it will displace copper from its salt. Zinc is more reactive than silver, means zinc will displace silver from its salt. So the most reactive metal is present at the top here is zinc. Then iron. Iron is more reactive than copper and silver. Copper is more reactive than silver. Now A shows displacement reaction with copper sulfate, means when A reacts with copper sulfate, it forms metallic copper and sulfate of A is formed. So it can be said that A is more reactive than copper. So A must be lying above copper in the reactivity series. Then B shows displacement reaction with iron sulfate, means when B reacts with FeSO4, it forms sulfate of B and iron is deposited. So it can be said that B is more reactive than iron. Then C shows displacement reaction with silver nitrate. So C is more reactive than silver. D does not show any reaction, means D is the least reactive metal present. Its reactivity is less than silver. So the reactivity of D is less than the least reactive metal in this series, which is silver. So D must be lying somewhere below silver. Now the questions. First, which is the most reactive metal? So most reactive metal is B. Then what would you observe if B is added to a solution of copper sulfate? Since B is more reactive than copper, B is lying above copper in this series. So B is more reactive than copper. So B will displace copper from copper sulfate. So B plus copper sulfate, you will get sulfate of B and metallic copper will be deposited. So this is the answer to the second question. Now third question, arrange the metals A, B, C and D in the order of decreasing reactivity. So B is the most reactive metal, then A, then C and least reactive is D. Now reaction of metals with acids. Metals react with acid, dilute acid to form salt and give hydrogen gas. Now sodium and potassium metals, they are very reactive metals. They react vigorously even with cold water. So sodium and potassium metals are not taken for the activity. Other metals like magnesium, aluminum, zinc and iron are taken for the activity to check their reaction with acids. Now magnesium, aluminum, zinc and iron, they all react with dilute hydrochloric acid to give salt and hydrogen gas. For example, magnesium plus HCl will form magnesium chloride MgCl2 plus hydrogen gas. Balancing the reaction, this is 2HCl. Then aluminium will react to form aluminium chloride and hydrogen gas. Now hydrogen gas is not evolved when metals react with nitric acid. Hydrogen gas is not evolved when metals react with nitric acid. Why? When metals react with nitric acid, whatever hydrogen is formed is again oxidized by nitric acid into water, and this nitric acid is reduced to any of the products like N2O, NO or NO2. This nitric acid, it gets reduced to any of the nitrogen oxides. So since the hydrogen produced is getting oxidized to water, whenever a metal reacts with nitric acid, it will not evolve hydrogen. But metals like magnesium and manganese are exception. Manganese and magnesium, when they react with very dilute HNO3, will give hydrogen gas. They will form the nitrate and they will give the hydrogen gas. Magnesium with dilute nitric acid will form magnesium nitrate plus hydrogen gas. The condition is nitric acid should be very dilute. Point to be noted, nitric acid must be very dilute. Rate of formation of bubbles when magnesium reacts with hydrochloric acid. The reaction is quite vigorous. When magnesium reacts with dilute hydrochloric acid, hydrogen gas is evolved. So this hydrogen gas bubbles are seen in the solution, and this bubble formation, the rate of formation of bubble was the fastest in case of magnesium. These are actually the bubbles of hydrogen gas, and the reaction is most exothermic in this case. Means when magnesium reacts with dilute hydrochloric acid, the rate of formation of hydrogen gas is very fast and the reaction is exothermic, that is, heat is evolved during the reaction, and in comparison to the other metals, the amount of heat evolved when magnesium reacts with hydrochloric acid is maximum. The reactivity decreases in the order magnesium, aluminium, zinc and iron. Iron is the least reactive. Magnesium is the most reactive metal when the reaction with dilute HCl is considered. In case of copper, no bubbles were seen and the temperature also remained unchanged. Means copper does not react with dilute HCl. So most reactive is magnesium. Copper does not react with dilute HCl. Then magnesium and manganese, they can react with dilute nitric acid, very dilute nitric acid, and give hydrogen gas, while other metals, when they react with nitric acid, hydrogen gas formed is oxidized by nitric acid into water. So they do not evolve hydrogen gas when they react with nitric acid. Instead, metal nitrate is formed, water is formed, and any of the oxides like N2O, NO or NO2 is formed. This is NO. Aqua regia. What is aqua regia? Aqua regia is actually a mixture of HCl and HNO3 in the ratio 3:1. And this aqua regia is highly corrosive, fuming liquid, and it is one of the few reagents that is able to dissolve gold and platinum. Next activity. In this activity, a solution of copper sulfate is taken in which iron nail is dipping, and a solution of iron sulfate is taken in which copper wire is dipping. Now this activity will help to find out which metal is more reactive. Now if a metal A displaces a metal B from its salt solution, then it is said that metal A is more reactive than metal B. Metal A is more reactive than metal B. For example, when iron reacts with copper sulfate, then the product formed is FeSO4 and copper. So what is happening? The salt taken was copper sulfate. Now what happens? Iron has taken the place of copper in copper sulfate. Means iron combines with the sulfate anion to form iron sulfate and metallic copper is deposited. So overall what has happened? Iron has displaced copper from its salt. So since iron has displaced copper from its salt, therefore it can be said that iron is more reactive than copper. So in this experiment, the blue solution of copper sulfate will fade and metallic copper will be deposited at the bottom of the test tube and iron sulfate will be formed. And in this test tube no reaction takes place because iron is more reactive than copper. Copper is less reactive than iron. So copper will not displace iron from its salt, that is iron sulfate. The reactivity series. What is reactivity series? Reactivity series is a list of metals arranged in the order of their decreasing activities. How do metals and non-metals react? First of all, take example of a noble gas like helium. Helium has atomic number 2 and it has 2 electrons in its valence shell. Then neon. Neon has atomic number 10. So its electronic configuration is 2, 8. So its valence shell or the outermost cell has 8 electrons. So its octet is complete. These noble gases do not react. They are inert gases, and the reason is they have either 2 electrons in the valence shell or 8 electrons in the valence shell. Means either duplet or octet is complete. So those metals and non-metals which do not have octet in their valence shell, they tend to lose electron or gain electrons so that the octet is complete. For example, sodium. Its atomic number is 11. So its electronic configuration will be 281. This is the K shell, this is the L, and this is the M shell. Or you can also say this is the first shell, this is second, and this is the third shell. Atomic number of sodium 11 means its number of electrons is 11 and number of protons in the nucleus is also 11. Now what happens if this sodium loses its outermost electron? The number of electrons present in its outermost shell or the valence shell is 1. What if it loses this 1 electron? So if sodium loses its 1 electron, it forms sodium ion. Now this sodium ion has electronic configuration 2, 8. It has lost 1 electron, so it has only 10 electrons, and the electronic configuration of sodium ion is 2, 8. So now sodium ion has 8 electrons in its valence shell, just like the noble gases. So sodium ion has configuration similar to neon. So octet has been achieved. So sodium ion will have a tendency to lose electron and attain the configuration in which it has 8 electrons in its valence shell. Now number of protons is 11. Number of electrons is now 10. In sodium ion, the number of electrons is 10 and the number of protons are present in the nucleus. Number of protons do not change. Number of protons is 11. So now the charge due to 10 protons will be balanced by 10 electrons, but this 11th proton, its charge will not be balanced. So sodium will get a positive charge. So number of proton is 11, number of electrons is 10. So one extra proton is present in the nucleus whose charge is not balanced by electrons. Therefore sodium, after losing one electron, gains a positive charge, forming sodium ion. And the configuration of sodium ion is similar to neon. So sodium has a tendency to lose electron, change into positive ion so that it gets neon-like configuration. Now if you consider non-metals, in non-metals chlorine, if you see, the atomic number of chlorine is 17 and its electronic configuration is 287. So in the valence shell of chlorine, only 7 electrons are present. What if chlorine gains 1 electron and changes into Cl- ion? Now this chloride ion will have the configuration 288. Now in the valence shell of this chloride ion, 8 electrons are present, and this chloride ion has attained a configuration similar to argon. Argon also has electronic configuration 288. So chlorine has a tendency to accept 1 electron, change into chloride ion so that it attains argon-like configuration. These are the stable configurations. Since the inert gases are having this configuration, other elements also tend to attain this configuration and become stable. Now in chlorine, the total number of electrons was 17. In chloride ions, the total number of electrons is 18. And in chlorine, the number of protons was 17. It had 17 protons. In chloride ions, there are 18 electrons. So the negative charge of 17 electrons will be balanced by the positive charge of 17 protons. But what about the one extra electron? This one extra electron will give chlorine a unit negative charge, because of which chloride ion has a unit negative charge. Now if you compare sodium and chlorine, sodium, it has electronic configuration 281. It can attain a configuration of 2,8 by losing electrons. So sodium ion 2,8. Chlorine, it has electronic configuration 2,8,7. It can attain a electronic configuration of 2,8,8 by gaining one electron. So it can be said that sodium loses one electron and chlorine gains this electron. Sodium loses one electron and chlorine gains this electron. Sodium changes into sodium ion, chlorine changes into chloride ion, and the compound which is formed is sodium chloride. Here this dot represents the electron present in the valence shell of sodium. Cross around chlorine represents the electrons, the 7 electrons present in the valence shell of chlorine. This 1 electron of sodium goes to chlorine. Now sodium and chlorine both have attained octet and they form the compound sodium chloride. And this compound is ionic compound because it is formed by the transfer of electrons. Occurrence of metals. Major source of metals is Earth's crust. Soluble salts like sodium chloride and magnesium chloride etc. are present in seawater. Now what are minerals? Elements or compounds which occur naturally in the Earth's crust. Are known as minerals. And what are ores? At some places, minerals contain very high percentage of a particular metal. And metal can be profitably extracted from these minerals. Such minerals are called ores. Now extraction of metals. If you see the reactivity series of the metals which are at the bottom of the reactivity series like silver and gold are the least reactive metals. And they are often found in free state. Apart from silver and gold, copper and platinum are also found in free state as their reactivity is also low. Copper and silver are also found in combined state in the form of their sulfide or oxide ore, means copper sulfide, copper oxide. So copper and silver are also present in the form of sulfide or oxide ores. Metals which are present at the top of the activity series like potassium, sodium, calcium, magnesium, aluminium. Potassium, sodium, calcium, magnesium, aluminium. These are very reactive and they are never found in nature as free elements. The metals in the middle of the activity series like zinc, iron, lead, etc. These are moderately reactive, means they are neither highly reactive nor less reactive. So their reactivity is at the moderate level and they are found in the Earth's crust mainly as oxides, sulfides or carbonates. Most of the metals are present as oxides. Ores of most of the metals are oxides. What is the reason? First reason is oxygen is very reactive element because of which it combines with the metals to give oxide. Second reason is oxygen is very abundant on the earth. On the basis of reactivity, metals can be grouped into three categories. First, metals of low reactivity. Second, metals of medium reactivity. And third, metals of high reactivity. Different techniques are used for obtaining the metals falling in each category. Several steps are involved in extraction of pure metals from ores, summary of which is given in the figure 3.10. These are the steps involved in the extraction of metals from ores. First step is concentration of the ore. The three types of metals are separated as metals of high reactivity, metals of medium reactivity and metals of low reactivity. For metals of high reactivity, electrolysis of molten ore is done to get the pure metal. For metals of medium reactivity, either carbonate or sulfide ore is present. If the carbonate ore is present, it is heated in the absence of oxygen, the process known as calcination, either absence of oxygen or in the limited supply of oxygen. So the process is known as calcination. Sulfide ore is heated in the presence of air or oxygen, sufficient amount of air or oxygen. The process is known as roasting. So both these methods convert the ore, the carbonate or the sulfide ore, into oxide of the metal. Oxide of the metal is reduced to get the metal, and finally the metal is purified. Metals of low reactivity. For metals of low reactivity, the sulfide ores are subjected to roasting, that is heating in sufficient amount of air or oxygen. The process is known as roasting. On roasting, the sulfide ore will get converted into its oxide. From the oxide ore, metal can be obtained by the process of reduction, and this metal is then subjected to refining. Enrichment of ores. Ores are usually contaminated with large amount of impurities like soil, sand, etc., and these impurities are called gangue. Now these impurities have to be removed from the ore before extracting the metal. Now what will be the processes used for removing the gangue from the ore? Whatever process will be used to remove the gangue from the ore will be based on the differences between the physical or chemical properties of the gangue and the ore. Based on the physical properties that are different between gangue and the ore, or the chemical properties that are different between gangue and the ore, based on the differences between the physical and chemical properties, the method of separation will be chosen. Different separation techniques are employed accordingly. Now, extraction of metals low in the activity series. Low in the activity series means the least reactive metals like mercury, silver, gold, copper. So metals low in the activity series are very unreactive. The oxides of these metals, they can be reduced to metals by heating alone. So just by heating the oxide of these metals will be changed into metals. Means, for example, cinnabar. Cinnabar is the ore of mercury and its formula is HgS. So it is sulfide of mercury. When it is heated in air means roasting, it is first converted into mercuric oxide. From mercuric sulfide, it is converted into mercuric oxide. So it is heated in air. So it combines with the oxygen of the air. Mercuric sulfide converts into mercuric oxide and sulfur dioxide gas is formed. This mercuric oxide, when it is heated, it will get reduced to mercury. Reduced means removal of oxygen. From mercuric oxide, oxygen will be removed and mercury will be obtained. So reduction is done by heating mercuric oxide. Just by heating mercuric oxide, it is reduced to mercury. Similarly, copper, which is found as Cu2s, that is cuprous sulfide, can be obtained from its ore by just heating in air. Cuprous sulfide, when it is heated in air, it combines with oxygen of the air to form cuprous oxide plus sulfur dioxide gas. On heating, the cuprous oxide reacts with the remaining cuprous sulfide to give metallic copper and sulfur dioxide gas. So metals low in the reactivity series can be obtained from their oxide just by heating. Their oxides are reduced to metals just by heating. Extracting metals in the middle of the activity series. Metals in the middle of the activity series like iron, zinc, lead, copper, these are moderately reactive. Take the example of zinc. These are present as sulfide ores and carbonate ores. These are present as sulfides and carbonates in nature. It is easier to obtain the metal from its oxide. So the sulfide of the metal and carbonate of the metal is converted into its oxide. To convert the sulfide ore into oxide, sulfide ore is heated in the presence of excess air. So it gets converted into the oxide. For example, zinc sulfide, when heated in the presence of excess of air, it combines with oxygen of the air to form zinc oxide and sulfur dioxide gas is given. To convert carbonate into oxide, the carbonate ore is heated in a limited supply of air. So, zinc carbonate on heating changes to zinc oxide and carbon dioxide gas is given. Now, heating in excess of air is termed as roasting, and heating in the absence of air or in a limited supply of air is termed as calcination. Now, once you obtain the metal oxides, to obtain the metal from metal oxides are reduced using reducing agents like carbon to give the metal. Zinc oxide, when heated with carbon, will give metallic zinc and carbon monoxide gas is obtained. Now, metal oxide can also be reduced by treating the metal oxide with a more reactive metal. For example, sodium, calcium or aluminium. When a metal oxide, for example MnO2, is heated with the more reactive metal, then the more reactive metal forms the oxide and the less reactive metal is obtained. But during this reaction, a large amount of heat is given out, because of which the metal that is obtained is in liquid state. Now here manganese dioxide is heated with aluminium powder. So aluminium is converted into its oxide. As aluminium is more reactive, it displaces manganese from its oxide and it forms aluminium oxide. So here aluminium is getting oxidized because oxygen is added to aluminium, while manganese dioxide is getting reduced to manganese. And during this process, a large amount of heat is evolved, because of which manganese metal is obtained in its liquid state. Similarly, Fe2O3 solid and aluminium, when they react, aluminium being more reactive is oxidized to aluminium oxide and iron is obtained as free metal, and the heat which is evolved in this reaction melts the iron and iron is obtained in molten state. So metals are produced in molten state, and the reaction of Fe2O3 with aluminium is used to join railway tracks or cracked machine parts, and this reaction is known as Thermit reaction. The molten metal which is obtained here will be used in joining the cracks in machine parts, or it is also used to join railway tracks. Again here aluminium is acting as a reducing agent and it is itself getting oxidized to aluminium oxide, whereas iron is getting reduced to metallic iron. Iron is losing oxygen and aluminium is gaining oxygen. This is also known as displacement reaction. Here iron is displaced by aluminium from its oxide to give free iron metal, and aluminium oxide is formed as the product. Properties of ionic compounds. Now in this figure 3.7, heating a salt sample on a spatula, some of the ionic compounds impart color to the flame. And figure 3.8, here testing the conductivity of a salt solution. Usually ionic compounds, they conduct electricity when they are in solution form. For example, sodium chloride when dissolved in water, it will give sodium ions and chloride ions. And due to the movement of these ions towards the oppositely charged electrodes, there will be flow of current through the solution. Physical nature of ionic compounds. Ionic compounds are usually solids, they are hard and brittle. Brittle means break into pieces when pressure is applied. Why are they hard? Because of the strong forces of attraction between the positive and negative ions. Melting and boiling point. They have very high melting and boiling points. What is the reason? The reason is a large amount of energy is required to break the strong interionic attractions, that is, to break the attraction or the ionic bond between positive and negative ions. A large amount of energy is required. Solubility. Electrovalent compounds means ionic compounds which are formed by the transfer of electrons are generally soluble in water and they are insoluble in solvents like kerosene and petrol. Now in this they follow the rule like dissolves like. Ionic compounds will dissolve in polar solvents. For example, NaCl, it is made up of Na plus and Cl minus ion. So it will dissolve in polar solvent, means solvent like water which have positive and negative end. And it will not dissolve in solvents like kerosene and petrol because these solvents are neither ionic nor polar. So ionic compounds tend to dissolve in polar solvents. Polar solvents means which have positive and negative poles. Conduction of electricity. Ionic compounds in solid state do not conduct electricity. Why? Because the ions are held at fixed positions due to strong electrostatic forces of attraction. But ionic compounds either in molten state or in solution, molten state or their solution in water, the ions, the positive and negative ions are free to move. So in molten state or as a solution in water, they can conduct electricity due to the movement of the ions. In molten state, the electrostatic forces of attraction between the oppositely charged ions are overcome due to heat. So these ions are free to move and conduct electricity. And in solution state, the ions are free to move, as a result of which they are capable of conducting electricity. But in the solid state, the ions are at the fixed position, they are not free to move, so they do not conduct electricity in the solid state. Write the electron dot structures for sodium, oxygen and magnesium. First, sodium. Atomic number 11, electronic configuration 281. So valence shell contains only one electron. So its electron dot structure will be sodium and the electron present in the valence shell. If it is denoted by a cross, this denotes the electron present in the valence shell of sodium. So this is the electron dot structure of sodium. Second is oxygen. Oxygen atomic number 8, electronic configuration 26. 6 electrons in the valence shell. So oxygen surrounded by 6 electrons in the valence shell. So this is the electron dot structure of oxygen showing the number of electrons present in the valence shell of oxygen. Third is magnesium. Atomic number 12, electronic configuration 282. This is the symbol of magnesium and the number of electrons in the valence shell is 2. The electrons in the valence shell are shown by cross. So these represent the number of electrons in the valence shell, that is 2. Next question is, show the formation of sodium, this will be sodium oxide, and magnesium oxide by the transfer of electrons. What are the ions present in these compounds? Sodium oxide has the formula Na2O. 2 sodium atoms having 1 electron in the valence shell. Oxygen atom has 6 electrons in the valence shell. Sodium transfers its electron to oxygen. This sodium atom also transfers its electron to oxygen. So each sodium atom gives 1 electron present in its valence shell to oxygen. So here each sodium atom gets a positive charge, forming a sodium ion. So there are 2 sodium ions and oxygen accepts 2 electrons from 2 sodium atoms and it gains 2 units of negative charge and it has 8 electrons in its valence shell. So 2 sodium ions and 1 oxide ion and the formula becomes Na2O. Similarly, in the formation of magnesium oxide, number of electrons in the valence shell of magnesium are 2. Number of electrons in the valence shell of oxygen are 6. Now magnesium having 2 electrons in its valence shell, it loses 2 electrons to form magnesium ion and having 2 units of positive charge, and these 2 electrons are given to oxygen. So oxygen gets 2 units of negative charge. So magnesium loses 2 electrons and gets 2 units of positive charge. Oxygen accepts 2 electrons and it gets 2 units of negative charge. So the compound formed is magnesium oxide having the formula MgO. And in the electron dot structure, magnesium ion, this is magnesium ion and this is the oxide ion having 8 electrons in its valence shell with 2 units of negative charge. And this is magnesium ion having 2 units of positive charge. Now in both these cases, sodium has electronic configuration 281 and when it loses one electron to form sodium ion, the electronic configuration of sodium ion is 28. Similarly, electronic configuration of magnesium is 282 and it loses 2 electrons to form Mg2 plus ions, and the electronic configuration of magnesium ion is 2,8. And oxygen, its electronic configuration is 2,6 and it gains 2 electrons to form the oxide ion O2 minus ion, which has electronic configuration 2,8. Now next question, why do ionic compounds have high melting points? Ionic compounds have high melting points because in ionic compounds the positive and negative ions are held together by very strong electrostatic forces of attraction, and it requires very large amount of energy to break these electrostatic forces of attraction. They usually exist in solid state and the ions are held together by strong electrostatic forces of attraction. To overcome this high electrostatic forces of attraction, very large amount of energy is required, as a result of which they have very high melting points. Define the following terms. Minerals. The elements and compounds present in the Earth's crust are known as minerals. Ore. Minerals. When percentage of certain metal is very high in a mineral, then that particular metal can be extracted profitably from that mineral. Such minerals are known as ores. What is gangue? Gangue is the impurity present in the ore. Second question, name 2 metals which are found in nature in the free state. Gold and silver. Why are they found in nature in free state? Because they are the least reactive metals. They are least reactive. They do not react with oxygen of the air. They do not react with any other gases present in the air. So they are found in free state. What chemical process is used for obtaining a metal from its oxide? The chemical process used is reduction. To obtain a metal from its oxide, reduction using carbon as reducing agent. Sometimes carbon is used as reducing agent and sometimes more reactive metals are used as reducing agent. Whichever metal you want to obtain from its oxide, just heat that oxide with a more reactive metal. More reactive metal will displace the required metal from its oxide, or the more reactive metal will reduce the required metal oxide. Another method is electrolytic reduction method. Some metals are highly reactive like sodium, potassium, magnesium, so they cannot be obtained by reduction of their oxides. So to obtain these metals, electrolytic reduction method is employed, where the molten chloride of the metal is subjected to electrolysis and metal is obtained at the cathode. Extracting metals towards the top of the activity series. Metals high up in the reactivity series, they are very reactive. They cannot be obtained from their compounds by heating with carbon. Carbon will not be able to reduce the oxides of sodium, magnesium, calcium, aluminium, etc. to the respective metals. What is the reason? The reason is that these metals are highly reactive and these metals have more affinity for oxygen than carbon. So carbon will not be able to remove oxygen from the oxides of these metals. Or in other words, carbon will not be able to displace the metals from their oxides. Because sodium, magnesium, calcium, aluminium, etc. or the metals higher up in the reactivity series have greater affinity for oxygen than carbon. Now, how to obtain these metals? These metals are obtained by electrolytic reduction. The reduction method used to obtain these metals is electrolytic reduction method. For example, sodium, magnesium, calcium, these are obtained by the electrolysis of their molten chlorides. For example, consider sodium chloride, molten sodium chloride. This sodium chloride will dissociate into sodium ion and chloride ion. Sodium ion is the positive ion, or it is also known as the cation, and this cation goes to cathode. Cathode is the negatively charged electrode. Chloride ion or the negative ion is also known as anion, and this anion goes to anode, and anode is the positive electrode. The reaction that takes place at the cathode is sodium ion accepts one electron and converts to neutral sodium atom, which get deposited at the cathode. Two chloride ions lose two electrons, form chlorine gas, which is liberated at the anode. So at the anode, chlorine gas is liberated, and at the cathode, sodium metal is deposited. Next is refining of metals. Metals produced by various reduction processes, they are not very pure. They contain impurities which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. Now, what happens in electrolytic refining? Many metals like copper, zinc, tin, nickel, silver, gold, they are refined electrolytically. In this method, the impure metal is made the anode and a thin strip of pure metal is made the cathode. And solution of metal salt is used as electrolyte. On passing current through the electrolyte, pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. Soluble impurities go into solution, and insoluble impurities settle down at the bottom of the anode and are known as anode mud. For example, here electrolytic refining of copper is shown. The electrolyte solution is acidified solution of copper sulfate. Copper sulfate dissociates to give Cu2 plus ion and sulfate ion. Anode is made up of impure copper and cathode is made up of thin strip of pure copper. Cathode is the negative electrode, anode is the positive electrode. On passing electricity through the electrolyte solution, what happens? Copper from the anode goes into the solution as Cu2 plus ion, giving 2 electrons, and same number of Cu2 plus ions from the electrolyte solution go to the cathode, accept 2 electrons and are deposited on the cathode as metallic copper. So at the anode, this is the reaction at the anode. At the anode, what is happening? Copper from the anode is going into the solution as Cu2 plus ion and losing 2 electrons. And at the cathode, the Cu2 plus ions from the electrolyte solution, same number of Cu2 plus ions from the electrolyte solution are going to the cathode, accepting 2 electrons and changing into metallic copper, which is getting deposited on the cathode. And whatever soluble impurities are there, they go into solution, and insoluble impurities collect below the anode as anode mud. At the end of this refining process, pure copper will be deposited from the anode to the cathode. At the end of this process, pure copper will be obtained at the cathode. Metallic oxides of zinc, magnesium and copper were heated with the following metals. Zinc oxide was heated with zinc, magnesium, copper. Magnesium oxide was also heated with zinc, magnesium, copper. Copper oxide was heated with zinc, magnesium, copper. In which cases will you find displacement reactions taking place? Now, Magnesium is more reactive than zinc and zinc is more reactive than copper. So when zinc oxide is heated with zinc, in this case no reaction takes place because oxide is of zinc and the metal is also zinc. But when zinc oxide is heated with magnesium, magnesium is more reactive than zinc. So magnesium will displace zinc from its oxide and it will form magnesium oxide and zinc metal will be formed. Similarly, when zinc oxide is made to react with copper, what happens? Zinc is more reactive than copper. So copper will not be able to displace zinc from its oxide, so no reaction takes place. Second case, magnesium oxide reacting with zinc. Again, magnesium is more reactive than zinc, so zinc will not be able to displace magnesium from its oxide. No reaction takes place. Magnesium oxide plus magnesium. So oxide is of magnesium, metal is also magnesium, no reaction. Magnesium oxide and copper. Copper is less reactive than magnesium, so copper will not be able to displace magnesium from its oxide. Next, copper oxide and zinc. Zinc is more reactive than copper, so zinc will displace copper from its oxide and it will form zinc oxide and copper metal. Then copper oxide and magnesium. Again, magnesium is more reactive than copper, so magnesium will displace copper from its oxide, forming magnesium oxide and copper metal. Then copper oxide with copper. Since oxide is of copper and metal is also copper, no reaction takes place. Which metals do not corrode easily? Gold and platinum are noble metals. They do not react. Their chemical reactivity is very less and they do not corrode easily. What are alloys? Alloys are homogeneous mixture of metal and non-metal or mixture of two metals. For example, brass. Brass is alloy of copper and zinc, and bronze. Bronze is alloy of copper and tin. And the properties of alloys are different from the individual metals. For example, the melting point of the alloys is less than the melting point of the pure metals. Then electrical conductivity of alloys will be less than the electrical conductivity of the pure metals from which they are formed. Which of the following pairs will give displacement reactions? Sodium chloride solution and copper metal. तो फर्स्ट है सोडियम क्लोराइड प्लस कॉपर मेटल. सेकेंड MgCl2 solution and aluminium metal. So MgCl2 plus aluminium. And third है FeSO4 solution and silver metal. And fourth है AgNO3 solution and copper metal. AgNO3 plus copper metal. तो सोडियम इज मोर रिएक्टिव देन कॉपर, तो ये वाली रिएक्शन नहीं होगी. कॉपर विल नॉट बी एबल टू डिस्प्लेस सोडियम फ्रॉम सोडियम क्लोराइड. मैग्नीशियम इज मोर रिएक्टिव देन एल्यूमिनियम, so aluminum will also not displace magnesium from magnesium chloride. Again, iron is more reactive than silver, so silver will not displace iron from its salt. Here AgNO3 and copper. In this case, copper is more reactive than silver. तो क्या होगा? Copper will displace silver from AgNO3 and the product formed will be copper nitrate CuNO3 whole twice plus silver metal will be formed. So correct option is option D. Next, which of the following methods is suitable for preventing an iron frying pan from rusting? Now point to be noted, this is iron frying pan, means it is used for cooking food. So applying grease, this method will not be applicable. Applying paint, no. And applying coating of zinc, correct. The suitable method to prevent rusting of iron frying pan will be applying a coating of zinc. An element reacts with oxygen to give a compound with high melting point. This compound is also soluble in water. The element is likely to be. Now the oxide which is formed has high melting point, means it is ionic in nature. It is ionic compound, and mostly metals form ionic compound. So it can be a calcium or iron. Most probably it is calcium or iron. But second point, it is given that the oxide is also soluble in water. Now oxide of iron is not soluble in water, but oxide of calcium is soluble in water. So element is likely to be calcium. Electrolytic cell. What is electrolytic cell? It is a device for using electrical energy to carry non-spontaneous chemical reaction. Food cans are coated with tin and not with zinc because zinc is more reactive than tin. You are given a hammer, a battery, a bulb, wires and a switch. How would you use them to distinguish between samples of metals and non-metals? Hammer. Metals, when they are hammered, they form sheets, and this property of metals is known as malleability. Whereas non-metals, they cannot be beaten into sheets. Second, a battery, bulb, wire and switch can be used to make a circuit. When metals are connected across this circuit, the bulb glows. Means metals are good conductors of electricity. Whereas non-metals are bad conductors of electricity. If a non-metal is connected in the circuit, bulb does not glow. So non-metals are bad conductors of electricity. Assess the usefulness of these tests in distinguishing between metals and non-metals. So metals can be beaten into sheets, that is, they are malleable. Non-metals cannot be beaten into sheets. Metals are good conductors of electricity, non-metals are bad conductors of electricity. Or non-metals are not good conductors of electricity. What are amphoteric oxides? Give two examples of amphoteric oxide. Two examples of amphoteric oxides are aluminium oxide and zinc oxide. Amphoteric oxides are the oxides which react both with base and acid. For example, aluminium oxide reacts with acid to form aluminium chloride and water. Now the balanced equation will be, this will be 2 to balance the number of aluminium, and this will be 3 to balance the number of oxygen, then to balance the number of hydrogen and chlorine. Now to balance the number of hydrogen and chlorine, this will be 6 HCl. As can be seen, aluminium oxide is reacting with acid to form salt and water. What is the physical state of these reactants and products? Aluminium oxide is solid. HCl, aqueous solution of HCl is taken. AlCl3, aqueous solution of AlCl3 is obtained, and water is in liquid state. Now reaction of oxide of aluminium with base. Al2O3 also reacts with base to give salt, that is NaAlO2, which is called sodium aluminate, plus water. Now to balance this reaction, this will be 2 to balance the number of aluminium atoms, and again here 2 to balance the number of sodium atoms. So this is the balanced equation. The physical state of the reactants and product is aluminium oxide solid, NaOH, aqueous solution of NaOH is used, sodium aluminate, aqueous solution is obtained, and water is in liquid state. So as can be seen, oxide of aluminium or aluminium oxide is reacting with acid as well as with base. So such oxides are known as amphoteric oxides. Another example of such oxide is zinc oxide. Now reaction of zinc oxide with acid, it reacts with acid to give salt and water, and zinc oxide also reacts with base like NaOH to give salt, which is known as sodium zincate, having the formula Na2ZnO2 plus water. Name two metals which will displace hydrogen from dilute acids and two metals which will not. Two metals which displace hydrogen from dilute acid calcium, zinc. These are the metals which displace hydrogen from dilute acids. And two metals which will not, copper and silver. Usually metals lying above hydrogen in the reactivity series, M denotes metal, will displace hydrogen from acids, whereas metals lying below hydrogen, M dash also denotes metals which lie below hydrogen in the reactivity series. So metals lying below hydrogen in the reactivity series will not displace hydrogen from dilute acids. So reaction of zinc with dilute acid will be zinc reacts with hydrochloric acid to form zinc chloride plus hydrogen gas is evolved, and calcium similarly reacts with HCl to give calcium chloride and hydrogen gas is evolved. Corrosion. What is corrosion? Some metals which are very reactive or moderately reactive metals, what happens? These metals, they get tarnished when kept in air because of the coating of oxide or carbonate or a hydroxide formed on their surface, and this is known as corrosion of metals. Some examples are silver articles become black after some time when exposed to air. Why? Because silver reacts with sulfur in the air to form a coating of silver sulfide. Silver reacts with the sulfur present in the air to form a coating of silver sulfide. Next, copper reacts with moist carbon dioxide in the air. Means it reacts with the H2O and CO2 present in the air and slowly loses its shiny brown surface and gains a green coating. This green substance is basic copper carbonate. Basic copper carbonate means CuCO3 and CuOH whole twice. So it forms both carbonate and hydroxide of copper on its surface, which is known as basic copper carbonate, and this is the green coating present on the surface of copper. So for the formation of basic copper carbonate, both carbon dioxide and moisture of the air are required. Iron when exposed to moist air, again moist air, for a long time acquires a coating of brown flaky substance called rust. Now conditions for the rusting of iron, take three test tubes A, B, C. In test tube A, there is normal water and iron nails are present in normal water. These are the iron nails dipping in normal water. Test tube B, boiled water with a layer of oil on the surface which prevents air from dissolving in water. Third test tube C, it contains dry air. Anhydrous calcium chloride is used as the drying agent. It does not contain water and anhydrous calcium chloride is added to absorb whatever moisture is there in the test tube. So in test tube A, both air and water are available. In test tube B, moisture is available, air is not available. In test tube C, air is available but no moisture is there. So what will be the observation? The observation will be iron nails rust in the test tube A, while iron nails present in test tube B and C do not show rusting. Iron nails present in test tube B and C do not rust. So what is the inference? For the process of rusting, both air and moisture are required. If any one of them is missing, rusting will not take place. Next is prevention of corrosion. The rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, anodizing or making alloys. When you paint the iron surface or put a layer of oil on the iron surface, what happens? The contact between the iron and the air is broken, as a result of which rusting is prevented. Since the iron is not in contact with the moisture and oxygen of the air due to the layer of the oil, no rusting will take place. What is galvanization? Galvanization is coating of iron with zinc or coating the iron with more reactive metal like zinc is called galvanization. When iron is coated with more reactive metal, for example zinc, zinc reacts with the oxygen of the air and prevents iron from rusting. So galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. The galvanized article is protected against rusting even if the zinc coating is broken. Again, the reason is same. Zinc is more reactive than iron, so it will react with the oxygen present in the air and prevent iron from rusting. Another method of improving the properties of a metal is alloying. We can get the desired properties by this method. For example, iron is the most widely used metal, but it is never used in pure state. What is the reason? Because pure iron is very soft and stretches easily when hot. But if it is mixed with a small amount of carbon, that is only 0.05% of carbon, if iron is mixed with 0.05% of carbon, it becomes hard and strong. In the same way, iron, when it is mixed with nickel and chromium, you get a stainless steel, which is again hard and does not rust. So iron mixed with some other substance, its properties change. Now properties of any metal, not only iron, properties of any metal can be changed if it is mixed with some other substance. The substance which are added to the metal, they may be a metal or a non-metal. Here comes the concept of alloy. So alloy can be defined as a homogeneous mixture of two or more metals or a metal and a non-metal, and it is prepared by melting the primary metal and then dissolving the other element in it in definite proportion. Then it is cooled to room temperature. What is pure gold? Pure gold, 24 karat gold, is very soft. It is not fit for making jewelry. But when it is alloyed with silver or copper, it becomes hard and it can be used for making jewelry. Generally, 22 karat gold is used for making ornament. It means that 22 parts of the pure gold is alloyed with 2 parts of either copper or silver. What is amalgam? Now when you are preparing an alloy, if one of the metals is mercury, then the alloy is known as amalgam. So alloy of a metal with mercury is known as amalgam. Now electrical conductivity and melting point of alloy is less than that of pure metal. For example, brass, which is alloy of copper and zinc. Brass is alloy of copper and zinc, and bronze. Bronze is alloy of copper. Bronze is alloy of copper and tin. They are not good conductors of electricity. Means their electrical conductivity is less, whereas pure copper is used for making electrical circuits. So the electrical conductivity of alloy of copper is less than pure copper. Solder, an alloy of lead and tin, it has low melting point and it is used for welding electrical wires together. Electrolytic cell. What is electrolytic cell? It is a device for using electrical energy to carry non-spontaneous chemical reaction. In electrolytic cell, electrical energy is converted into chemical energy. Now this is the diagram of electrolytic cell. It consists of a cathode, anode. Cathode is the negative electrode connected to the negative terminal of the battery. Anode is the positive electrode connected to the positive terminal of the battery, and in the cell there is a electrolyte solution. Usually process of electrolysis is used in electrolytic refining and electroplating. One of the examples of electrolysis reaction is electrolysis of molten NaCl. If you carry out electrolysis of molten NaCl, NaCl breaks into Na plus and Cl minus ions. Na plus ion is the cation, Cl minus ion is the anion. The positive ion is the cation and the negative ion is the anion. The cation goes to cathode, positive ion goes to the negative electrode, that is the cathode, anion goes to the anode. Now what is the reaction taking place at cathode and anode? At the cathode, what ion is there at the cathode? Sodium ion. Sodium ion will accept one electron and change into sodium metal, which will be deposited at the cathode. And what is the reaction at the anode? At the anode, Cl minus ion, that is the negative ion, lose electron and change into chlorine atoms, and two chlorine atoms combine to give chlorine gas. So overall reaction at the anode becomes two chloride ions forming chlorine gas and losing two electrons. In the electrolytic refining of a metal M, what would you take as the anode, the cathode and the electrolyte? Anode will be impure metal. Anode will be made up of impure metal M. Cathode will be of pure metal M, and electrolyte will be a salt of metal M. Electrolyte will be a salt of metal M, which will furnish the ions of the metal. Pratyush took sulfur powder on a spatula and heated it. He collected the gas evolved by inverting a test tube over it, as shown in figure below. What will be the action of gas on first dry litmus paper, second moist litmus paper? Sulfur powder is taken and it is heated. When sulfur powder is heated, what gas is formed? Sulfur powder, when it is heated, now it is heated in atmosphere, means it is heated in the presence of oxygen. So sulfur powder reacts with oxygen to form sulfur dioxide gas. Now first part of the question is, what will be the action of gas on dry litmus paper? Means what will be the action of sulfur dioxide on dry litmus paper? Sulfur dioxide gas will not react with dry litmus paper, will not show any change in the color of dry litmus paper. Why? Because of the absence of H plus ions. Because of the absence of H plus ions, the color of the litmus paper will not change. Second, moist litmus paper. Moist litmus paper means there is water present on the litmus paper. So what happens? Sulfur dioxide gas reacts with this water present on the litmus paper and it forms a sulfurous acid. This sulfurous acid furnishes H plus ions, and in the presence of H plus ions, the color of blue litmus will change to red, because sulfur dioxide is acidic oxide. Since it is acidic oxide, when it reacts with moisture, it forms acid. It forms acid. The acid is sulfurous acid here, and acids turn the color of blue litmus paper to red. This is the balanced equation for the reaction taking place. Mole concept. What is mole? Mole can be related to atomic weight. Mole can be related to molecular weight. Mole can be related to number of particles, and mole can also be related to volume. 1 mole of atom, 1 mole of atom in terms of weight means atomic weight of atom. For example, 1 mole of carbon means 12 gram of carbon. 12 gram is the atomic weight of carbon. Similarly, 1 mole in terms of molecular weight. 1 mole of any molecule, for example carbon dioxide, will be equal to 44 grams of carbon dioxide. 44 grams is the molecular weight of carbon dioxide. Then in terms of number of particles, 1 mole of any substance contains Avogadro number of particles, which is equal to 6.022 into 10 to the power 23 particles, and Avogadro number is denoted by Na. So 1 mole is equal to Avogadro number of particles. And as far as volume is concerned, 1 mole of any gas, for example 1 mole of oxygen gas, 1 mole of oxygen gas will occupy the volume 22.4 liters. This is the volume occupied by oxygen gas. This volume is known as molar volume. This is also known as molar volume. Give reasons why copper is used to make hot water tanks and not steel, an alloy of iron. Copper metal does not react with water, whether it is cold water, hot water or steam. Whereas steel, which is an alloy of iron, this iron which is present in the steel will react with steam. It will react with the steam to form oxide. As a result of which, if hot water tank is made up of steel, then slowly it will corrode because the iron present in the steel is reacting with steam to form oxide of iron. Steel tanks will corrode after certain period of time, whereas the copper tanks, if a tank is made up of copper, since copper does not react with steam, cold water or hot water, copper tanks are preferred over tanks made up of steel. Moreover, copper is a good conductor of heat in comparison to steel. Give reasons why copper is used to make hot water tanks and not steel, an alloy of iron. Copper metal does not react with water, whether it is cold water, hot water or steam. Whereas steel, which is an alloy of iron, this iron which is present in the steel will react with steam. It will react with the steam to form oxide. As a result of which, if hot water tank is made up of steel, then slowly it will corrode because the iron present in the steel is reacting with steam to form oxide of iron. Steel tanks will corrode after certain period of time, whereas the copper tanks, if a tank is made up of copper, since copper does not react with steam, cold water or hot water, copper tanks are preferred over tanks made up of steel. Moreover, copper is a good conductor of heat in comparison to steel. You must have seen tarnished copper vessels being cleaned with lemon or tamarind juice. Explain why these sour substances are effective in cleaning the vessel. Copper vessel. Tarnished copper vessel means when copper is exposed to atmosphere, then it reacts with the moisture of the atmosphere and carbon dioxide present in the atmosphere, and it forms basic copper carbonate. Basic copper carbonate. Basic copper carbonate contains copper carbonate as well as copper hydroxide. Copper carbonate is a salt and copper hydroxide is a base. Now what happens? This lemon contains citric acid and tamarind contains tartaric acid. So this acid, citric acid and tartaric acid, when the copper vessel is cleaned with lemon or tamarind, when it is cleaned with lemon, this citric acid reacts with copper carbonate and copper hydroxide, when it is cleaned with tamarind. Then tartaric acid reacts with copper carbonate and copper hydroxide. The layer of this basic copper carbonate is removed from the surface of copper. So this is the reason why these sour substances are effective in cleaning the vessels, because the acid will react with the base and the salt which is present in basic copper carbonate, and these get dissolved in the acid, and the layer of this basic copper carbonate is removed from the surface of copper, and the original shine of copper is restored. Next question is, differentiate between metal and non-metal on the basis of their chemical properties. Now, metals and non-metals. Usually what happens? Metals form basic oxides. What is the meaning of basic oxides? Means these oxides, when they are dissolved in water, they form bases. And non-metals form acidic oxides. Acidic oxides means when these oxides of non-metal are dissolved in water, they give acids. Then metals are capable of giving hydrogen when treated with dilute acids. For example, a metal M, if it is treated with HCl, it will form the salt, that is the chloride, and it will give hydrogen gas. Whereas non-metals are not able to give hydrogen gas with acids. Metals, they react with water and they form the hydroxide and give hydrogen gas. Non-metals do not react with water easily. Non-metals do not give hydrogen with water. Next is, metals usually form ionic compounds. For example, sodium chloride. Sodium is the metal. It reacts with chlorine to form sodium chloride, and this is a ionic compound. Whereas non-metals, they form covalent compounds. For example, carbon tetrachloride. This is a covalent compound. Metals, they lose electrons to form positive ions, and non-metals, they gain electron to form negative ions. So metals, they lose electron and have a tendency to form positive ion, means they act as reducing agents. Whereas non-metals like chlorine, they have a tendency to accept electron and form negative ion, so they act as oxidizing agent. So these are some of the differences between metals and non-metals on the basis of their chemical properties. Now, reaction of metal with water, metal oxides with water. For example, calcium oxide. Calcium is a metal. It reacts with water. Calcium oxide reacts with water to form a base, that is calcium hydroxide. Whereas non-metal oxide, take the example of carbon dioxide. Carbon is the non-metal. It will react with water to give carbonic acid. So metals form basic oxides and non-metals form acidic oxides. Basic oxides react with water to give base. Acidic oxides react with water to give acid. Then metal reacting with HCl to give hydrogen gas. Example, sodium metal reacts with HCl, it will form sodium chloride and it will give hydrogen gas. Then metal reacting with water to give hydrogen gas. Again, sodium can be taken as example. Sodium reacts with water to give sodium hydroxide and hydrogen gas, and a large amount of heat is also evolved during this reaction. Now, calcium oxide reacting with water to form calcium hydroxide. In this reaction also heat is evolved. State 2 ways to prevent the rusting of iron. Rusting of iron prevent करने के लिए painting, then applying grease. Iron surface को अगर grease से cover कर देंगे, then what happens? Contact between the iron and the oxygen and moisture present in the air will be broken, so rusting can be prevented. Oiling also prevents rusting. the iron utensils in the kitchen, if they are coated with a layer of oil, then they do not rust, because the contact between the iron and the atmospheric oxygen and moisture is broken. So these are some of the methods, and another method is galvanization. In galvanization, iron is coated with a layer of zinc, a very thin layer of zinc. Now what happens, zinc is more reactive than iron. Zinc जो होता है वो iron से ज़्यादा reactive होता है, so it prevents rusting of iron. So coating iron with a thin layer of zinc is known as galvanization. So this is one of the methods to prevent rusting of iron. What type of oxides are formed when non-metals combine with oxygen? Non-metals, when they combine with oxygen, they give acidic oxides. For example, carbon when combines with oxygen, it forms carbon dioxide. Sulfur when combines with oxygen, it forms a sulfur dioxide gas. क्यों बोलते हैं इनको acidic oxides? Because carbon dioxide when dissolved in water, it forms carbonic acid, and sulfur dioxide when dissolved in water, it forms sulfurous acid. Since non-metallic oxides when dissolved in water give acids, therefore non-metal oxides are called acidic oxides. So if a moist litmus paper is brought near carbon dioxide or sulfur dioxide gas, then a moist blue litmus paper will turn to red. Give reasons. Platinum, gold, silver are used to make jewelry. First of all, they are malleable, they are ductile, they have shine, they are lustrous metals, and the most important property is that they are the least reactive metals. Least reactive metals, or you can also say they do not react at all with the atmospheric oxygen or air. Therefore, they are used to make jewelry. Sodium, potassium and lithium are stored under oil. Now, in this case, the reason will be sodium, potassium, lithium, they are the most reactive metals. They react with the oxygen of the air, and sometimes the reaction is so vigorous that they may catch fire. So they are kept under oil. Aluminium is highly reactive metal, yet it is used to make utensils for cooking. First of all, it is a good conductor of heat, and second, it gets coated with a layer of its oxide, and then it does not react with the food at a high temperature. Since it gets coated with a layer of its oxide, it will not react with the food at high temperature, so it is used for making utensils for cooking. Carbonate and sulfide ores are usually converted into oxides during the process of extraction, because it is easier to extract the metal from their oxide than from their carbonate and sulfide ores. क्या होता है कि metal oxide when reduced with carbon forms the metal and carbon monoxide gas is formed. Another way in which metal is obtained from metal oxide is metal oxide is made to react with a more reactive metal. Then what happens? The more reactive metal forms the metal oxide, and the required free metal is obtained. For example, metal oxide, it is made to react with the more reactive metal like M dash. So M dash will form the oxide, and the free metal will be obtained from the oxide. So it is easier to extract the metal from oxide. Therefore, carbonates and sulfate ores are usually converted into their oxides during the process of extraction.